So now we actually have to go through and create a database, so we have somewhere to put all this. So to do that, we'll flip back to Visual Studio. And the place I like to start is actually in the app data folder to first set up our database. So what we're going to utilize here is a SQL Server technology called LocalDB, or local database. To utilize LocalDB, you have to have, at minimum, SQL Server Express running on your local machine. I believe it has to be version 2012 or higher. If you installed Visual Studio completely, including the data tools, which I told you you should, then you should have SQL Server installed on your development machine. If you're utilizing the VLabs for any reason, I can't guarantee anything. Basically what happens with LocalDB is that we're going to create an MDF file, which is the database data file. We're going to create a local database file, put it inside of our project under app data, and then at runtime, we're going to attach that MDF file to the SQL Server, and the SQL Server will connect it, instantiate it, and then allow us to actually run SQL commands against it. And then once we're done running our process, it'll detach it from the SQL Server and release those resources. So it's made specifically for small deployments or local database development. The reason it uses the MDF is because the goal is that you would then take that MDF file once you're moving into production, and you would take it and put it on the SQL Server and actually attach it to a live SQL Server. Change your config file to point to that server, and then that would be your production SQL instance. So locally, as you're developing, you keep it local, you attach it on demand. In production, you deploy the file, and then you attach it to the server. The other nice thing about the LocalDB is that you can keep it inside the project. So if you're using source control, that project, or rather that database, gets backed up into your source control if you're using GitHub or anything like that. So it keeps that copy current. So in case you blow away your machine or you're sharing source code, you can make sure that you're running with the latest version of the database. All right, so to add a LocalDB MDF, you want to right-click on the app data folder, go to Add, New Item. Visual Studio is pretty smart. It knows the app data folder is there for specific things. We'll want to choose the top one, which is SQL Server Database. For me, I'm going to name my MDF file 15fs projdb. And basically what's happening is that MDF file is getting generated, stored inside my app data folder. The LDF that comes along for the ride is the log file. So just kind of as a reminder, or if you don't know this, your SQL Server especially has two components. There's the data file, and then there's the transaction log. All of the SQL actions that you do, your updates, deletes, inserts, are transactionalized, which means that you can actually isolate them. You can do an insert, you can do an update, and then you can do what's called a rollback. So none of that data actually gets committed or written to the MDF file until you commit the transaction. Typically, when you're in SQL Management Studio, you write an insert statement, you hit F5 or push the little execute button, and once it finishes executing that little chunk of code, it commits the transaction, and then your data is saved. There's actually ways to begin a transaction, and then if an error occurs, you can roll back transactions or commit them, depending on your case. It's a little beyond the scope of this class, but 5 seconds. So MDFs and LDFs. They both need to be there. The logs, you can technically delete them, but you run the risk of losing suspended transactions. So MDFs definitely want to keep them. All right, so we have an MDF and an LDF. You can double click on that MDF file, and when you do so, Visual Studio will spin up SQL Express, do a LocalDB attachment, and then show it to you in the Server Explorer. Mine's on the left-hand side. And the Server Explorer is basically there to allow you to browse different server resources. So inside of my MDF is nothing, literally nothing. Brand new database. How many of you have created a database from scratch? Okay, a good number of you. Did you guys do it at Co-op, DB2, when DB1?
DB class.
DB class? Okay.
Did you create that one?
What?
For your class, didn't we have to make a database?
You did.
Yeah.
Yeah.
For your, this is on still in the view part where it says validate message for, where it says new class text danger.
Yeah.
Did you add that, or was that the class had that already?
That came as part of the scaffolding when it created the file. When it created the view, when I picked my model class and all of that, that came as part of it generating that file form.
Oh.
So all that's basically saying is the text danger is a coloring for the text to make it red.
All right.
So this rendered out to be that message that came up when the text boxes were all empty.
All right.
Does that make sense? Yeah. Yeah. If you take programming classes with me, you use database. So, all right. So we're going to go through and actually create a database table. So the easiest way that I like to approach it is, and I go different ways depending on where I'm at in the development process, but since we've already created our view model, we'll kind of work backwards, and we'll go back and then create our database table. So I'm going to start by right-clicking on tables. I'm going to say add new table. And I'm going to make this table called users. Now, the designer within Visual Studio is a little different than what you see in SQL Server Management Studio. It's different in that it gives you both the SQL and the designer at the same time. The part that I personally hate is that you have to do both the SQL and the designer at the same time to get a database table created correctly. Because there's other ways of doing it, and it just becomes even more clicks. So at the top, you have your column definitions, just like you would see in SQL Management Studio. You can go in, type in your names, your types or a drop-down, allow nulls, defaults, all of that's in there. As you make changes up top, this T-SQL that actually gets run by the server gets generated, so it's fun. You can see what code is actually being created to create your database. You can actually take this code and back it up to a SQL file. You can save it, and that way if you need to do new database creation in a production environment, you can actually have those original scripts for creating your tables. You can add triggers, foreign keys, indexes, constraints, and primary keys all inside of the design piece at the top. Same goes down below. If you know the T-SQL you want to use, or if you copy it from somewhere else and need to make some modifications, you can paste it in and the designer will respond accordingly. So, for our table, we need the following fields. First name, and I'm going to do varchar 400. I'm not going to allow nulls. Last name, varchar 400. Email, varchar 400. Username, varchar 400. Password, varchar max. Does anybody here have enough curiosity to ask me why?
For varchar max.
Close enough. Better question would be, go ahead.
It says because like the encryption, like the salt or whatever plan on using.
Well, actually, the varchar max isn't the one. isn't the one I'm worried about. It's why did I pick 400? Doesn't that seem kind of like a random number for me to pick? So the reason, that's the why question. Why'd you pick 400? The reason is that when you index fields within a SQL server, there is so many bytes that field can be before it's not allowed to be indexed. And the reason I always remember 400 is that not the varchar, but the nvarchar can only go up to about 400. Nvarchar is a Unicode encryption, varchar is ASCII. So I always just remember 400 because it's safer, and typically you don't have names or email addresses that are that long. So I always try to restrict my character fields to 400 unless I'm not planning on putting indexes in them. Now, when you get into encryption and different kinds of encryption, and especially when you get into high-bit encryption, you don't know how many characters that encrypted string will turn into, so the max is always a safe bet. That, and typically you're not searching on a password field. So when you build an index is a lookup, so you're not going to be looking up somebody by their password. And if you are, you probably shouldn't be, because it's probably doing something illegal. So, but I could look up by email address, I could look up by username, I could even do a search on first and last name combined, and that index can't be more than 900 bytes. Kilobytes. Bytes. Bytes? Yes. So, 2 400 character fields keeps you within that boundary. So, that's our table. One last thing that we need to do is we need to identify the ID field as the identity column. It is our primary key, but it's not the identity, which means that it won't auto-increment or auto-number. In order to do that, we actually have to flag it as being the identity. You can do that by clicking and highlighting that column, going to Properties. There is an identity specification property here. Is identity false? You double click on it, makes it true. That's the easy way to do it. The easier way is to come down here and type the word identity and you're done. So that's the part about sometimes it's easier just to type it in instead of digging for it. Another thing that I often run into is you have to remember to actually give your table a name. So that lives under properties as well. I always have to go over here and I have to click on the designer, not on a column, just on the designer, come back to the properties dialog, go up to name, and then change it. Again, that's a lot of clicks. It's just as easy for me to come down here into the T-SQL, and I call it users.
What used to be user?
Why does it matter?
I thought one supposed to when we're using this under specific cases since it's per user when it's singular.
Say that again.
Since like only one time this is supposed to represent one user when it just be user.
Oh, okay. That's fine. We can go either way. The problem with user, though, is that user is a keyword within SQL. What?
Square brackets.
So you put it in square brackets. And just remember to put your square brackets in every time you write a query. Alright. Now the other thing that I hate about this designer is that if you try to go and save this, because you want to save the table to the database, right? So you do something like in Control S, it'll come up and say, okay, where do you want to save it to? And then it gives you the option to save it to a .SQL file. It's saving the script, it's not actually it's not putting the table in the database. So you don't want to do a save, you can, but that's not the objective here. You actually want to click this update button in the designer. The designer will then go through and do a series of validation steps to make sure that you can, in fact, make the change. It'll check foreign key constraints and other values prior to committing the change, just to make sure that you can do it. In this case, it's our first table. It's one table. It's not a big deal. We'll hit Update Database. It'll go through, generate the appropriate SQL scripts, generate the right transactions, and then perform the update. This little tool is kind of beyond the scope of the course, but there is an entire project type inside of Visual Studio that's committed simply to handling database revisions and updates and deployments. It's actually called a database project. And it's fun because you get the same designer interface, but you're saving those SQL files, and then you go through a deployment process of pushing out database changes via the scripts. What's especially nice about it is that it'll script an entire new database build if you need to. So if you're actually pushing this to production, you don't take the MDF file necessarily and copy it. You may take that script and run it against the server and say, go create a database using these scripts, these create statements, these insert statements, and so forth. This tool will actually diff a pre-existing database versus what's designed, and it'll generate the update and change scripts. So if you add a new field to a database table or delete a field, it'll actually create change scripts for you to go in and make those changes to the database instead of trying to recreate tables. So keep that in the back of your head.